So today we're going to talk about friction. Alright, so just consider an occasion where you try to move a block on a table. Right? It's not that easy to move a block on the table. Why is that? When you try to move the block forward, there's kind of an opposition that you feel backwards. Or when you try to move the mobile phone that is placed on the table forward, there's this opposition that you feel backwards. So this opposing effect is friction. Right? Now when you try to swim in the waters, you feel an opposition, an opposing force. So friction can occur between solid surfaces, it can occur within fluids. Fluids constitute liquids and gases, but friction within fluids is generally known as viscosity. Alright, so let's observe this diagram given below. So you can see the object is in vertical equilibrium. Why? The reaction upon it upwards is equal to what? The weight of the object. So there is no net force in the vertical direction, therefore it's in vertical equilibrium. Now just think of an occasion where you're trying to move the block forward. When you try to move the block forward, the ground exerts a force on the object backwards. Right? And then the object exerts a force on the ground forward. So this is what we call friction, the backward force exerted from the ground upon you, right? So if you are the object, the backward force that you exert, that you experience is what? Friction. So now just think of increasing the external force little by little, right? Let's say you increase the external force from 2 newtons to 4 newtons and so on. Then what happens? There is going to be friction that is also going to increase with your force. So if you apply 2 newtons, friction is going to be 2 newtons. If you apply 4 newtons, friction is going to be 4 newtons. But this is not always the case. I'm just giving you an example. So what happens here is that friction initially is self-adjusting. But friction has a limit. Friction has a maximum possible value. The maximum possible value of friction depends on the 2 surfaces in contact and also the object, the weight of the object. Right. So, okay, what happens is when you keep on increasing the external force, friction also increases along with it, but only up to a certain limit. This is easier to be explained through a graph. So yes, if you look at this graph here, when you increase the external force that you apply, so this is the external force that you apply, force F. Initially, if you apply 2 newtons, friction is going to be 2 newtons. I'm just giving values for you to feel it. If you apply 4 newtons, friction is going to be 4 newtons, and so on. But let's say you apply a force of 8 newtons, friction is going to be 8 newtons. But if you apply a force greater than 8 newtons on this hypothetical location I'm talking about, let's say you apply a force about 10 newtons, friction cannot exceed 8 newtons because I mentioned this 8 newtons is the maximum possible value of friction. So when you apply a force greater than 8 newtons, what happens is the friction value drops a little. And then friction enters a stage called dynamic friction. So before dynamic friction, there was this self-adjusting stage of friction where according to the force that I apply, friction is also going to have the same force value. But as we understood before, friction has a maximum possible value. And the maximum possible value of friction is called the static limiting friction. Right? If you apply force beyond it, friction is going to drop a little and then stabilize at a constant value. So whatever the force that you apply beyond 8 newtons, 10, 12, 14, whatnot, right? Then the friction is going to be stabilized at a constant value. Alright, I will come back to the graph to give you essential components of the discussion. So, alright, so let's understand this. Furthermore, Frictional force is the self-adjusting force that occurs against an external force. That is what we understood. Self-adjusting force that occurs against an external force, which causes slipping between surfaces or a tendency to slip. Very important words. Alright, so what's the meaning of a tendency to slip and slipping? Well, when you initially apply an external force, if the external force that you apply is less than the maximum possible value of static friction, right? Static friction is when there's no relative motion between the two surfaces. Think of an occasion where the object is not moving as of yet, but you are applying an external force and the object isn't moving as of yet. So on that occasion, when you apply an external force, there's going to be a repulsive force, a resistive force, that is the friction. That is the static friction. And the maximum value of that static friction is called static limiting friction. Right? So what I was trying to say was, okay, let's say you apply a force which is less than the maximum possible value of friction. Well, then the object is not moving anywhere, right? Is that clear? It's not moving anywhere. We're considering an occasion where the object is initially at rest, right? So if the object isn't moving anywhere, but still you create a certain kind of a tendency, an encouragement, a tendency to move, don't you? You kind of create a tendency to move. If the force that you apply goes beyond the maximum value of static friction or exceeds static limiting friction, there is going to be a relative motion between the two surfaces, and then we enter the situation called slipping. The object slips on the surface. Then there's going to be a relative motion between the two surfaces. I hope you understood that. Alright. So let's understand the sentence again. Frictional force is the self-adjusting force that occurs against an external force, which causes slipping between surfaces or a tendency to slip. So these surfaces are in contact with each other. Alright. So now let's come to some laws of friction. Until the object starts moving, the frictional force increases with the external force. Right? So until upon the occasion where you find relative motion, or before the object starts to move, according to the force that you apply, friction is going to vary. If you apply 2 newtons, friction is going to be 2 newtons. If you apply 4 newtons, friction is going to be 4 newtons. Until the force that you apply exceeds the maximum possible value of friction that we understood very well. Right? So this friction has to be understood, right, along with the external force that you apply. The maximum frictional force that occurs without slipping between the two surfaces is called the static limiting friction that we understood. Now, this static limiting friction is proportional to the normal reaction, right? This static limiting friction is proportional to what? The normal reaction. Okay. What are they meaning by the static limiting friction? They're talking about this maximum friction value. They're talking about this maximum friction value, right? That is proportional to the normal reaction. The normal reaction in the sense, the reaction that the object experiences vertically upwards. Okay, you can see something very important here. The maximum frictional force, right? The maximum frictional force, right? Or the maximum static friction force is not depending on the external force. It actually is related to the reaction experienced by the object. Okay, if the object has a higher weight, the maximum static limiting frictional force is going to be high. if the reaction is lower, which means if the weight is lower, right, what will happen? The frictional value is going to be lower, right? It's not always about the weight. More accurately, it's about the reaction. Now, why is that? Now just think of placing an object on a surface and there's a reaction upwards. All right, on this occasion, here's the weight of the object is equal to the reaction. Yes, on this occasion, the reaction is equal to the weight of the object. But just think of an occasion a bit different from this. Think of an occasion where I apply force F downwards, and now I have the weight downwards as well, but there's the reaction upwards as well. But now the reaction is equal to what? The downward force that you applied plus the weight, which means, more accurately, friction is proportional to the maximum value of static friction is proportional to the reaction, not the weight. Because the reaction is controlled by some other factors beyond the weight. It is equal to the weight if there's no external influence other than your weight, right? So you have to think about that deeply. All right. So don't accept any of these things. You have to question, get into the subject, right? Examine by yourselves. The thought process in understanding physics is very important. You shouldn't memorize these concepts. Try to understand it, digest it, right? Okay, so now let's come to the second point. I think we already discussed about this. The maximum frictional force that occurs without slipping between the surface is called static limiting friction. And you can see this F max is proportional to the reaction on the object. Now if you want to get an equation, you should have a constant here after the proportionality. So you're going to have a constant of mu s. This mu s is the coefficient of static friction. So mu s is equal to F max over the reaction. So mu s depends on both the surfaces, right? So think of the object and the surface. If the surface is kind of gritty like this, and if the object surface is also gritty like that, so both have an effect on what? The friction that's occurring between the two surfaces, right? When the force applied exceeds the static limiting friction, the object starts to slip, right? So I mentioned about this. When you apply a force greater than the static limiting friction, there's going to be relative motion, because now there's going to be a resultant force. Because the force you apply is greater than the maximum value of friction, then there's going to be a resultant force, which means the object is going to move forward. And then friction doesn't die. Friction is going to lower its value a bit from the static limiting friction value, and then stabilizes at a constant value, as we saw in the graph. In the graph here, right? All right. Okay, so then the object starts to slip. The frictional force that occurs during slipping in the presence of relative motion is called dynamic friction, or it's called kinetic friction. So the kinetic friction is proportional to the reaction again. It's beautiful. It's again proportional to the reaction. But the thing is, it's equal to something called mu k into r. Mu k is actually the coefficient of kinetic friction. But did you observe something very important here? The value of dynamic friction or kinetic friction is lower than the value of maximum static limiting friction, or the value of static limiting friction. So then, if both of these frictional forces are proportional to the reaction, you should understand that mu k has to be lower than mu s. Okay, you'll understand that better through this. You know that static limiting friction is greater than kinetic friction, but static limiting friction can be written as mu s r, and kinetic friction can be written as mu k r. Coefficient of static friction is mu s, and coefficient of kinetic friction is mu k. So once the reaction cancels off, you can see mu s is greater than mu k. All right. So you can see the maximum static limiting friction F max is bigger than Fk, which is the dynamic friction. Very important points. Dynamic friction doesn't depend on the velocity of the object and the surface area in contact. Right? So remember, friction doesn't depend on the surface area in contact. Friction just depends on the reaction and the nature of what? The surfaces in contact. Right? Alright, so you can see here the graph we already discussed, right? So initially the force that you apply, the external force, is equal to the frictional force, but then there's a maximum value of friction that is called the static limiting friction, and beyond it, if you apply a force, what happens? Yeah, you enter a stage called dynamic friction, where even though you increase the external force, the frictional value is going to remain stagnant, constant. Alright, to apply F equals mu r to an object, the object should be at static limiting equilibrium, or the object should be slipping. You cannot apply F equals mu r in a region like this. Why can't you apply F equals mu r in a region like this? That's because in a region like this, or in a region like this, friction is not proportional to, it is not proportional to r. It's not proportional to r, right? It's not proportional to r. It's not proportional to the reaction. The friction in this region is basically proportional to the force that you apply. Right? If you apply 2, it's 2. If you apply 4, it's 4. So in this area, in this segment, you cannot apply F equals mu r. But in this area here, in this area here, you can apply what? F equals mu r. Very important for solving MCQs. Alright. Okay, so this is just a question that I've discussed in another class, so I'm not going to do this here. So we'll come to questions in a while. Alright, so we'll be discussing some questions now. First, I want you all to attempt this question alone. Pause the video, try it out, give your best thought. Maybe it takes several days. Give your maximum effort, think and think and think, and then you can listen to the discussion. That's the best thing you can do. Right, a trolley A is on a horizontal track. B is a wooden block of mass m. If the coefficient of static friction between the trolley and the block is mu, the minimum acceleration of the trolley that is required to prevent the block from sliding down is. This is a very simple question. What you have to do first is to mark a free body diagram. So if you can see here, as the trolley A moves forward, B is pushing back on A. When B pushes back on A pushes on B forward. So you can see then these forces that they exert upon each other can be marked as reaction forces. So R and R, right? So then now just think, how is B going to be in vertical equilibrium? For B to be in vertical equilibrium, the frictional force that occurs upwards has to be equal to what? The weight downwards. Otherwise there won't be vertical equilibrium, right? So then you can see, considering all these factors, considering the block B, I can apply F equals MA. Remember, in F equals MA, the F stands for the external unbalanced force. Right, so I can write R is the external unbalanced force acting on B forward. So R is equal to MA, mass into acceleration. We are talking about the forward direction. Right? Also, I can write an expression for the friction. Now you can see they are asking for the minimum acceleration of the trolley that is required to prevent the block from sliding down. So when the block is just about to slide down, what's the minimum acceleration that you require? Then we're talking about what? We're talking about static limiting friction, right? So just about to slide, the friction is at a maximum value equal to what? Mu s r. That's equal to Fs, mu s r, right? That's a static limiting friction. Now the static limiting friction is equal to mu s r, and if that static limiting friction occurring upwards, when the object is trying to fall down, the friction is occurring upwards, opposing, right? So it's occurring upwards. So when this friction becomes equal to the weight, I can write an expression. Frictional force is equal to the weight of the object B. Fr is equal to mg, right? Fr is equal to mg for vertical equilibrium. Then I can write, instead of the frictional force, mu r, right? So mu r is equal to mg. Then I can get an expression for the reaction as mg over mu, right? So now I can apply F equals ma to object B. Remember, we applied F equals ma to object B. We did that, right? We did that. So then when you apply F equals ma to object B, R is the resultant force forward on object B. That's equal to ma, and the reaction is equal to, we found it out, mg over mu. We did that here, right? Then you can see mass cancels off, and then what we are left over is for the acceleration g over mu, right? So listen to the discussion several times to really understand it. Okay, so try your best first think about the questions and then give it a try. All right, so let's come to the next question. A box is placed on a horizontal surface and horizontal force F is applied on the box. Variation of the magnitude of F with time is shown in the graph. Which of the following shows the possible variations of the magnitude of the frictional force Ff acting on the box with time? Okay, it's a very simple question. Now just suppose, think of this one. This is the external force that you apply with time. Now suppose if this external force is having values like, okay, from 0 newtons, let's say it has values up to 5 newtons, and then continuously it's 5 newtons, right? 5 newtons. Here, let's say 4 newtons and so on, right? 4 newtons and so on. All right, something wrong with my, okay, right, 4 newtons, right? So now think, what if the static limiting friction has a value greater than 5 newtons? Suppose static limiting friction, right? If static limiting friction is equal to, let's say, 6 newtons, okay, then the force that we have applied is below the static limiting friction. Then whatever that happens to the external unbalanced force should happen to the friction if the external unbalanced force is less than the static limiting friction. So one possibility is for the friction to vary like in B. The same variation of the force can be the same variation of friction, because what if this variation of the forces that they have depicted is less than the maximum possible value of friction? So give it a thought. You don't have to accept what I'm saying. You can argue, debate it out and see. That's science, right? Alright, so now just think, what if suppose if the static limiting friction value is about 4 newtons, if that is about 4 newtons, you can see, well, the external unbalanced force has exceeded what? It has exceeded the static limiting friction. Then if that is the case, friction would increase along with the external force up to 4 newtons, right? Along with the external force, friction would increase up to 4 newtons. So again, there's a problem, right? Hope it's fine now. Yes, I think I have to take a separate space for the explanation. I'll take it here, right? So what I was talking about was, right, suppose if the frictional force, the maximum value of the frictional force is equal to maximum value is equal to 4 newtons. So it will vary up to 4 newtons like so, just like the external force, right? This kind of a curve up to external force. Beyond 4 newtons, if the external force varies beyond 4 newtons, if it increases beyond 4 newtons, friction would decrease a little and then remain constant. And here we enter the stage of dynamic friction, right? Dynamic friction. So you can see then there's another choice that is eligible, choice D. You can't take choice C and you can't take choice A. Why can't you take choice C? There's a reason for that. You cannot take choice C because initially the frictional force is linear, right? But you can see the external unbalanced force that you apply initially is in a curve. So the initial behavior of the external force has to be equal to what? The frictional force as well, right? So see, the theory that we learned is directly applied here, right? All right, now let's do another question and see. So a box of mass 50 kg is placed on a horizontal floor, bed of a lorry as shown in the figure. The coefficient of static friction between the box and the floor bed is 0.8, and the lorry accelerates along a straight horizontal road. The maximum acceleration the lorry can have so that the box will not slide over the floor bed is equal to. Alright, so the maximum acceleration that the lorry can have so that the box will not slide over the floor bed. So you know, when the lorry accelerates forward, right, the block is trying to move away backwards, then there's going to be a friction forward, right? So think of this, I will keep a gap between the object A and the floor of the lorry, right? Object A and the floor of the lorry, I'll keep a gap. So you can see when the lorry moves forward, there's a tendency for this A to go backwards. But when it's trying to go backwards, you feel it, right? You feel as if when you're on the lorry, you feel like you're being pushed backwards. That very perception is the reason for the frictional force to occur forward. Right? The frictional force occurs forward. This frictional force is the very reason that A is going to have an acceleration forward. See the beauty of physics, right? So when A is tempted to go backwards, there's going to be friction forward, so that A is going to have the same acceleration of the lorry. So they're asking the maximum acceleration the lorry can have so that the box will not slide over the floor bed. Now suppose if the lorry goes very fast, especially more than the speed, if the lorry accelerates a lot, speed doesn't really matter, but if there's a high acceleration for the lorry demands for the block also to have a high acceleration in order to keep up with the lorry. But suppose if the acceleration is very high, the block is not able to have that acceleration. Why? Because the block gets the acceleration due to friction, and there's a maximum value for the friction. If in case the acceleration demands a force of friction, right? Now let's say the block moves forward at a tremendously high acceleration. Then the block cannot keep up. Why? Because the frictional force is not able to provide that acceleration. So in this question, they're asking you, what is the maximum possible acceleration that would keep this box in place on the lorry floor, right? So, okay, I hope you understood that. So you can mark the frictional force like so, the reaction and the weight and so on, right? So you can see the reaction is equal to the weight mg, frictional force is equal to mu r. We're talking about the maximum static limiting friction because we're talking about the maximum acceleration. So Fr is equal to mu mg. This frictional force is the very reason for there to be an acceleration. This is the external unbalanced force acting on the object to give it an acceleration. So F equals ma, I can apply that to the block. Fr is equal to ma, so frictional force is equal to mu mg, that's equal to mass into acceleration. So you can see acceleration is equal to mu into g, so acceleration is equal to 0.8 into 10, so you'll find out the acceleration to be equal to 8 ms minus 2. Alright, the last question for today. Okay, if you observe this diagram, as shown in the figure, force P is applied on an object of mass 2 kg lying on a horizontal surface. The coefficient of kinetic friction between the two surfaces is 0.5. If the object moves with a uniform velocity, the normal force R acting on the object is. Alright, so how would you solve this question? So they have mentioned that the object moves with a uniform velocity. So if the object moves at a uniform velocity, what you can understand is the frictional force occurring on the object has to become equal to what? The forward force exerted on the object. So if I draw the object, you can see when I apply a force P like so at an angle, there are components of the force. P sine 45 is the downward component, P cos 45 is the component acting in the plus x direction. Right, so P sine 45 contributes to increasing the reaction on the object because it's acting downwards, reaction on the object increases. P cos 45 is acting forward, so it's trying to accelerate the object forward. But they have mentioned in the question that this object goes at a constant velocity, which gives us a clue that P cos 45 has to become equal to the friction. P cos 45 has to become equal to the friction. Right? I hope you understood that. Alright, so then I can say, now if you look at the value of friction, we have to talk about dynamic friction, right? Because it's moving, they're slipping. So this friction value for dynamic friction is given by mu kr. Right? I hope you can remember that. Alright, so, but the reaction is equal to P sine 45 plus mg, because P sine 45 is acting downwards along with the weight downwards. So P sine 45 downwards plus the weight downwards, right, gives you the total reaction upwards. Because the total downward force, P sine 45 plus the weight mg, has to become equal to the reaction in order for there to be a vertical equilibrium. Okay, so the frictional force, as we know, is also equal to the horizontal force. Right, frictional force backwards is also equal to the horizontal force P cos 45. Because the object goes at a constant velocity, these two forces have to cancel off. Alright. Now, F is equal to P over root 2, because cos 45 is root 2. P over root 2, mu into, what is the reaction now? P sine 45 is also P over root 2 plus the weight mg. So when you simplify this, you can see P over root 2 minus mu P over root 2. P over root 2 into 1 minus mu is equal to mu mg. P over root 2 is equal to mu mg over 1 minus mu. Reaction is equal to what? P over root 2 plus mg. Then I know P over root 2 is equal to what? Mu mg over 1 minus mu. Then having substituted the information in the question, you can get the reaction to be equal to 40 newtons. So you all have to try it out, right? So I hope you all understood the lesson. Do this question. You can refer to the theory again. Right. Have a nice day.